This video is going to go over isosceles and equilateral triangles, which there's a lot of properties in here that will apply to a lot of different solving situations that we're going to see. So a couple reminders: isosceles triangle has at least two congruent sides. We've seen that before. The legs of an isosceles triangle are the two congruent sides. The vertex angle is the angle that's formed by the legs. The base is the third side of your triangle. There are two base angles in an isosceles triangle, and these are the two angles that are adjacent to the base. So they're the red angles over here on the right hand side in my picture. The base angles theorem is one of the most important ones, and that's if we have two sides of a triangle that are congruent, then we know that the angles opposite them are congruent. So when we're looking at this figure over here on the right hand side, since we see that AC is congruent to AB, then we know that angle B is congruent to angle C. With the converse theorem, we start if we know that the two angles of a triangle are congruent, then the sides opposite them are congruent. In our picture over here on the right, we see that the angles, we start with the angles being congruent, so then we know that AB will be congruent to AC. We can see in this first picture that if we know that DE is congruent to FD, then the two congruent angles are opposite those two sides. So if you draw arrows going across from those two sides to the opposite corner, or the opposite angle, that would be angle E and angle F. So angle E is congruent to angle F. So next I would like you to try the same idea. So start with that HG is congruent to HK and draw your symbols in your picture, and then find the angles that are across from them, and then start with the angles that they give you that are congruent, and then that will tell you the different sides that will be congruent. So go ahead, push pause, work out your answer, and then you can push play when you're ready to check your answer. Alright, so these are the markings you should have for HG is congruent to HK. So this means that our angle G will be congruent to our angle K in that first triangle. But notice angle K could really be either side of it, so we need to make sure we're using three letters to label it. So it'd be angle HKG, or you could say GKH. So next, what your picture should look like with your markings of the two congruent angles are these two markings in red. So then that tells us that KJ will be congruent to HK. Really, if you think about it, if we know that KJ is congruent to HK, but we already know that HK is congruent to GH, then all three of them are technically congruent to each other as well. So this is something a little more specific about equilateral triangles. And if a triangle is equilateral, then it is also equiangular, which means that all three angles are congruent. This can also go the opposite direction, so if a triangle is equiangular, so all three angles are congruent, then it is also equilateral, which means that all three sides are congruent to each other. So in this next picture, we see that angle P, we want to figure out what P, Q, and R measurements are, so you see that the three sides are congruent. So this is an equilateral triangle, so that means that it's equiangular. And if you think about it, if all three angles have to be congruent, 180 degrees is what they need to add up to be. So this would mean we would have 3x equals 180, which gives us that each measure of those angles are 60 degrees each. Is it possible for an equilateral triangle to have an angle measure other than 60 degrees? And that would be no. And it's because if it's equilateral, it has to be equiangular, and equiangular for a triangle, we know that they have to be 60 degrees. These last three are three really good questions to make sure you're writing down. The first one, you need to find what the values of x and y are in our picture. So in our picture, we can see there's two different types of triangles. We have an equilateral, or really it's equiangular triangle up here, and then we have an isosceles triangle down below. So if you look at it, we know that all three sides in this first triangle are going to be congruent, so we know that the k value will be 4 as well. But then to find the x value, we have to extend it out to this third side in that triangle, but then these two sides in the triangle will be congruent because our opposite angles are congruent. So I know that x plus 1 also has to equal the 4. So when I set up an equation with that, I'm going to get that x is equal to 3 once I solve for the x. So in the next picture, if we solve for x and y, I would like you to try this one on your own. It's the same idea. So go ahead and push pause, work it out, and then come back and check your answer. Alright, so we can see that this triangle with the x value in it is an equilateral triangle since all three sides are the same, so that means that the x value has to be 60 degrees. And for that reason, this 90 degrees here in the corner, that means that the leftover little angle has to be 30 degrees since they have to be 90 degrees together. And then this other angle over here also has to be 30 degrees because it is an isosceles triangle, and we have, if these two sides are congruent, then the base angles have to be congruent. So I know this base angle is 30, so the other one also has to be 30. And now I know that the three angles together, so 30, 30, and my y, have to add up to be 180 degrees inside that triangle. So here's an equation I can use to solve this. So I know that my 30 plus 30 is my 60. And then when I solve for y, I get 120 degrees. This last problem, you have to draw a picture. So go ahead and draw your picture and label it with the three measurements. And remember that all three angles have to add up to 180 degrees. You can set up an equation to solve for x that way, and then you can plug it back in to find the different measures of the angles to identify what type of triangle, right, triangle DEF is. So go ahead, push pause, and work out the whole problem, and then you can come back and check your answer. Alright, this is what your picture should look like with all your measurements in there. So your equation should look like this. When you solve for x, you should end up with x equals 16. And this is the work on how to get that. What we need to do is take that 16 and plug it back into each of the different measure angles to figure out what the degrees are. So when we plug it back into E, we end up with 66 degrees. When we put it back into angle F, we get a 48 degrees. And when we put it back into angle D, we also get 66 degrees. Since two of the measures of the angles are the same, that means that we have an isosceles triangle, so that the opposite sides are also congruent. So it's an isosceles triangle, plus all three angles are below or less than 90 degrees. This is an acute triangle, so an isosceles acute triangle.